But yeah, we've got Died here today from the Panoptic team to do a live code walkthrough of what's in scope for their competition that went live literally 30 seconds ago. So perfect timing. Died, all yours.
Thank you. All right, so yeah, excited to be running this contest. I'll give a little bit of background on the contest first, I guess. So the prize pool, and let me know if you can see my screen all right. The prize pool for the contest is $80,000. If there are high severity issues found, if there are medium severity issues found, it's $50,000. And then if there are low severity findings, there's a $5,000 pool for low severity and informational findings. Additionally, and this is something that you may not have seen before, there is a follow-up competition. So if there are any high or medium severity issues found during the main contest, all of the researchers who found those issues will be invited to sort of like a fixed review / pre-deployment review contest, and that contest will have a prize pool of $20,000. So basically $100,000 in total here if you're able to find any higher medium severity issues. So yeah, I guess that's the background of the contest prize pool. So yeah, without further ado, let's get into the code review. So yeah, let's talk about Panoptic. So some of you may have audited Panoptic in one of our previous contests. We've had several competitive audits with Code Arena on previous versions of our code. So you may be familiar with it, but if not, I'll give a quick intro here. So Panoptic is a permissionless options protocol built on top of Uniswap v3. Essentially, it's a liquidity lending protocol. So Uniswap v3 positions have options like payoffs, and the Panoptic protocol effectively allows you to lend and borrow Uniswap v3 positions. And this is kind of how we create options. So to sell an option, you effectively just create a Uniswap v3 position, and to buy an option, you borrow that position. So it's kind of the basics on how Panoptic works. We call it an options protocol, but at its core, and the system that you will actually be auditing is a lending protocol for Uniswap liquidity. So this contest itself is not over our protocol built on top of Uniswap v3. It's actually a port of our protocol built on Uniswap v4. So if we go back to the contest page here, you'll notice that I've included two diffs here. So we recently had our final fixed review audit with Code Arena for what we call Panoptic v1, which is a liquidity lending protocol for Uniswap v3 positions. And there are kind of two diffs here since that audit. The first diff in scope is just a small diff with a few fixes from our last Code Arena audit and a few tweaks. This is very small, and this will be what is effectively the final version of Panoptic deployed on Uniswap v3. Now the second diff is our upgrade, which we call Panoptic v1.1, and this is the port of Panoptic v1 or to Uniswap v4. So this is the main thing that you'll be auditing, and effectively it's going to be the exact same system as Panoptic v1, but there will be a few API changes and kind of logistical changes to make Panoptic work with Uniswap v4 positions. So yeah, I think I'll probably I'll go through Panoptic v1, which is kind of the version of Panoptic here built on top of Uniswap v3, and I'll do a walkthrough of that code, and then after that we can kind of go through the Uniswap v4 related changes for Panoptic v1.1 and see what changed. I think that's probably the best way to do it. Honestly, it's not a whole lot. As I said before, it's exactly the same system, but there are some significant changes that we would need to go over. So yeah, I think we'll start with Panoptic v1, which is built on top of Uniswap v3. And I'll do like a quick overview of the contracts, and then I'll go through each one. So yeah. We have a couple core contracts in Panoptic. The first and like the most basic or the most important one, we call the semi-fungible position manager. This is basically an alternative to Uniswap's non-fungible position manager. And it's what it sounds like. It's effectively just a position manager for Uniswap v3. And its main functions are add, just like the non-fungible position manager that's already in their periphery. It's adding and removing liquidity to Uniswap v3. The difference with the semi-fungible position manager is that it has more options like APIs, so you can create like multiple liquidity chunks encoded in the same position, and you can also like specify a position that removes liquidity from a chunk, which will be important in the lending and borrowing of liquidity. Now, this is still just a position manager. There's not any kind of lending going on in here. This is just something that the Panoptic pool uses to facilitate the lending of the Uniswap positions. So yeah, that's the semi-fungible position manager. The Panoptic pool is the contract that actually facilitates the Uniswap lending. So it allows you to create option positions, sell options positions, and then buy option positions by borrowing long liquidity. And it handles liquidations and all the other kind of mechanisms that exist in the protocol. And then the collateral tracker is an ERC-4626 vault that kind of feeds tokens into the Panoptic pool. And this allows you, and this is effectively an isolated, or I don't know what the word is, but an isolated lending protocol that allows you to borrow tokens and then use them to create Uniswap positions, which is useful when you're kind of trying to create different payoffs. So if you just use your if you just use USDC to create a Uniswap position on the ETH-USDC pool, your payoff will be a short put. But if you borrow ETH and then use that to create a position, then your payoff becomes the delta between the amount of tokens you borrowed and the amount of tokens in your position. So the payoff becomes a short call instead. So anyway, yeah, the point is that we allow you to borrow tokens from depositors in this collateral tracker, and you kind of pay commission fees, which kind of acts as interest for those people who are lending out their tokens to people creating or selling those Uniswap positions. So yeah, effectively that's the collateral tracker. It's just a vault, and then also it performs some of the collateral calculations. Chiefly, just it's able to value different Uniswap v3 positions in terms of how much they're worth, and then use that to determine whether an account is solvent or not. So that's the basic purpose of the three contracts. Semi-fungible position manager is just a Uniswap. It's just a Uniswap position manager with some extra features that we added. It's maybe a little bit more gas efficient. The Panoptic pool is kind of the entry point that everyone mints options through. It allows you to borrow tokens from the collateral tracker to mint option positions, and kind of lend and borrow liquidity. So yeah, and one thing I'll also note is that the semi-fungible position manager is it's also somewhat of a public good. So even though the Panoptic pool uses the semi-fungible position manager to create option positions, anyone else can also use this position manager to manage their own liquidity without going through Panoptic. So technically, this is kind of a standalone contract, and it can function outside of Panoptic. But Panoptic does kind of use this contract to perform all of its functions. So kind of the basic overview of the three contracts. Let's see. So yeah, every Panoptic system has one Panoptic pool, and then two collateral trackers, one for each Uniswap token. So if you have the ETH-USDC pool, you'll have one Panoptic pool for the ETH-USDC Uniswap pool. And then you'll have a collateral tracker for ETH and a collateral tracker for USDC. And these will kind of allow just people to deposit each token into the pool and lend them out to people who are creating options. And then there's only one SPM for all of the different Panoptic pools. So the SPM manages liquidity across every single Uniswap pool effectively. So yeah, that's kind of the basic overview of the contracts. There's like a list of actors in the system here that I probably touched on earlier. But anyway, yeah, so Panoptic liquidity providers or PLPs are users who lend out their tokens for people to create Uniswap positions with. And this effectively enables leveraged Uniswap LPing. So users, as I said, yeah, they deposit tokens into these ERC4626 collateral tracker vaults, and then option sellers borrow those tokens to create positions. And then instead of receiving interest based on like the utilization of the tokens or whatever, the option buyers and sellers just pay commission fees. And the expectation is kind of that the Panoptic liquidity providers will receive a regular income from new options being created and receiving kind of commission fees on the tokens that were borrowed. So obviously, yeah, option buyers and sellers, so people who are creating options, these are also PLPs because they deposit tokens into these vaults as collateral. So anyway, yeah, option sellers, these users deposit liquidity into the Uniswap pools through Panoptic, and this is effectively lending the liquidity to option buyers to borrow. So this kind of has the same payoff as lending liquidity directly to Uniswap v3. There are some benefits to doing this through Panoptic. One of the benefits is, of course, that you can borrow tokens from these PLPs, and you can create leverage positions as well as kind of combine to create different payoffs. You can do, and our founder, Guillaume Lambert, has a few articles on Medium about how he did this that are linked in this README above. You can also do this through normal lending protocols where you kind of borrow tokens, then use them in Uniswap positions to kind of modify your payoffs. But you can also, but Panoptic makes this really easy and really capital efficient. And then also the second benefit, and probably the most important one, is that the users that you lend to, so your liquidity is deposited in Uniswap, but if somebody borrows your liquidity and removes it from Uniswap, they pay you a multiplier on the Uniswap fees that your position would have earned based on how much liquidity has been utilized in whatever chunk you were borrowed. This can be up to 3.25x. So you can earn a significant increase on the amount of fees that you would have earned had you just deposited that liquidity from Uniswap. And these fees are kind of paid by the option buyers. So yeah, option buyers, kind of similar to option sellers, they also deposit collateral. The difference is that they borrow liquidity from option sellers and remove it from Uniswap. And this obviously kind of gives them the opposite payoff as option sellers. So instead of having a short call payoff, if you borrow that position instead, you have a long call payoff. So anyway, yeah, this is these option buyers. This is kind of the new thing that is enabled by Panoptic. You can now borrow Uniswap positions and use that to create long option payoffs and effectively buy options on any asset with a Uniswap v3 pool. So yeah, these are kind of like the main user roles or actors who are actually using the protocol. There are also these two extra actors, liquidators and forced exercisers. Liquidators, yeah, as it sounds like, they liquidate option sellers and option buyers who their positions are they don't have enough collateral to sustain their positions. So if an option seller borrowed a bunch of tokens to create a Uniswap v3 position, and that position accrues a bunch of impermanent loss, then the liquidator will come in and kind of forcefully close their positions and provide any tokens that were that were missing from their collateral to close their positions. And then option buyers, they are borrowing these Uniswap positions from option sellers, and they owe them a multiplier on the Uniswap fees. So if their collateral is no longer enough to cover the Uniswap fees that they owe the option sellers, the liquidators will come in and close their account. And then the last one is forced exercisers. So this is kind of an option that is available to option sellers. So if you sell an option and the current price moves out of range, then your option will no longer earn any fees because the pricing model for the fees paid by option buyers for borrowing the option seller liquidity is a multiplier on the Uniswap fee. So of course, if the current price is out of range and nobody's swapping, then you will not be earning any fees. So the forced exercise allows you to forcefully close long positions if the current price is far enough out of range. And that effectively allows you to remove your liquidity. Otherwise, you would have a situation where you sell a bunch of liquidity, and then the price moves far out of range, and somebody borrowed your liquidity, and they would not be able to. You effectively would not be able to close your position. So that's the forced exercisers. So yeah, that's kind of a basic overview of the protocol. I'll actually start walking through the code now. So yeah, I think the best place to start here is the semi-fungible position manager. So as I mentioned before, this is kind of a standalone Uniswap position manager. It's used by the rest of the Panoptic protocol, but it doesn't facilitate the minting and burning of options directly. It's just a Uniswap position manager that's kind of done through. And this is probably actually the thing that changed most between Panoptic v1 and Panoptic v1.1, because this is obviously interacting directly with Uniswap. Obviously, the Panoptic pool and the collateral tracker, they're querying Uniswap for prices and other things like that. But the semi-fungible position manager is the contract that's actually adding and removing liquidity from Uniswap and doing the swapping. So with Uniswap v4, we had to make a kind of a levy of changes to the semi-fungible position manager to add support for that. So yeah, this is probably going to be the most important one to look at and where the majority of the changes are. So I'll do like a quick overview of the Uniswap v3 version of this contract on Panoptic v1. And then we'll have a look at the changes that were made to this contract in Panoptic v1.1. So anyway, yeah. Let's go through here. So yeah, the semi-fungible position manager, you input a factory into the constructor, so it can validate callbacks from Uniswap pools. And then the flow here, when you want to start trading a Uniswap pool on the semi-fungible position manager, the first thing you do is initialize it. And effectively, all this does is generate a pool ID for that Uniswap pool, which is kind of it's a unique identifier for that pool, but in a smaller number of bits than the address. And the reason we do this is because when you mint and burn positions in the semi-fungible position manager, they're kind of represented as a token ID. So there's a 200. So this is, yeah, I probably didn't mention this, but this contract is an ERC 1155. So effectively, how it works is you have what we call a token ID, and we can probably have a look at this type. Or it's in the types folder. But you have a token ID, which is the ERC 1155 token ID, and this specifies all the details of the Uniswap v3 position that you're creating through this position manager. And yeah, as I mentioned, it can specify up to 4 different Uniswap liquidity chunks, and then the balance of the ERC 1155 position represents the size of the token ID. So initializing the Uniswap pool just kind of creates a unique ID for the Uniswap pool that's used in the token ID, because the token ID is limited to 256 bits. So anyway, yeah, there's kind of a diagram here, but yeah, so this is kind of how the token ID is structured. This is a custom type or user-defined value type in Solidity. If you don't know what this is, it's essentially just an abstraction over a value type. In this case, it's U56. And then there's a bunch of helper methods that you can call on it. And we use this to kind of do the bit packing on this 256-bit type. But anyway, yes, these are all the different parameters in here. This is the pool ID that we generate when we initialize a Uniswap pool in the SOPM. And so this is only 48 bits. And then we cache the tick spacing in here to save some gas later on. But anyway, the interesting part is these 4 legs. So yeah, for each token ID in the SOPM, you can create between 1 and 4 Uniswap liquidity chunks. And each of these legs kind of codes for a specific chunk with a tick lower and a tick upper. And then the amount of liquidity is determined by the position size of the chunk. So the way we size positions is a little bit interesting. So if you look at this asset here, the position size or the ERC 1155 balance in the SOPM that you mint is not actually the amount of liquidity that you mint in Uniswap. It's an amount of one of the tokens in the Uniswap pool that's converted to an amount of liquidity. So effectively, you specify the size of each leg in the position or each of the legs by converting the position size to a liquidity chunk that has that amount of tokens when it's out of range. And there's some Uniswap functions like get amount 0 for liquidity or get liquidity for amount 0 and get liquidity for amount 1 that we use to do this. But yeah, effectively, so if your position size is 2,000 USDC, then your leg will be 2,000 USDC when it's out of range. If that makes sense. Anyway, so yeah, this kind of specifies what unit the position size is in. Typically, this will be the same for all legs. You can create legs with different assets. This won't really work very well, obviously, because you'll be interpreting the same position size in kind of in terms of a different token. So unless the prices are very close, unless the prices are very similar in Uniswap, you'll probably want to set this to the same for each leg. So either token 0 in the Uniswap pool or token 1 in the Uniswap pool. Now the option ratio, this is effectively a multiplier on the position size, and it allows you to create legs of varying sizes. So if I want to create like a 2-leg position, and I want one of the legs to be twice the size or twice the amount of liquidity as the other, I will set this to 1 for the first leg and 2 for the second leg. And the position size will be effectively multiplied by 2 before being translated into an amount of liquidity for that token ID. So that's what the option ratio is. Is long, this is whether the leg is long or short. Short legs mean that you are adding liquidity to Uniswap. Long legs mean that you're removing liquidity to Uniswap. So if you're just using the SOPM as kind of a standalone position manager, this probably won't be very useful to you because you'll be removing your own liquidity. But the Panoptic pool, this is what you use to remove other people's liquidity. So that's kind of where it becomes relevant. So effectively, if you mint a position with is long equals 1, you will remove the amount of liquidity you would have added if it was is long equals 0, and then if you close that position, the liquidity gets added back. Now the token type, this is more relevant for the Panoptic pool, but effectively the token type is the token that is borrowed to create the Panoptic position. So an example I mentioned earlier, where if you're on the ETHUSDC pool and you use USDC to create your position, you have a short put payoff. Panoptic allows you to borrow different tokens to create the position. So you can either borrow some USDC and use that to create your liquidity. And we have a feature that allows you in the SOPM to swap to the constituent tokens if the position is in range or in the money. But yeah, so effectively, this just specifies which token you're borrowing from the Panoptic liquidity providers. So if I wanted to borrow ETH to create a position in the ETH USDC pool, and ETH was token 1, I would set this. To 1. Risk partner. So this is a way. This is kind of like an optional feature. So we have a preset number of strategies that you can create that have lower collateral requirements. So for certain options combinations like strangles or straddles or spreads, the risk of two different legs of an option or two different liquidity positions is different or is lower combined than when they're separate. So if you have a straddle, for example, I don't know if anyone here has ever seen it, but basically it just looks like a little mountain. So your payoff kind of starts at the top, and then as the price moves to the right, the payoff goes down, and then so this is the short call payoff. And then if you also create a short put, the payoff also goes down this direction. But obviously the price can only move in one direction at one time. So if you create if you create a short put and a short call, the risk when they're combined is half of the risk of them individually, because you can only lose money on one leg at one time, if that makes sense. So this is kind of a way to optionally reduce your collateral requirement by using like a number of preset strategies that we've coded into the collateral calculation. And so you'll just you'll point the legs to each other. So if I want to risk partner leg 1 and leg 2, I would, and this is actually leg 0 and leg 1 encoded in the token ID, but I would set the risk partner on this leg to 1, and then I would set the risk partner on this leg to 0. And then we validate those risk partners before you're allowed to mint the position. So if you do risk partner to approved legs, then you may be able to lower your collateral requirements. So kind of the context there. And then the strike and the width. These are the parameters that you use to actually specify the chunk of liquidity that you're going to mint in Uniswap. So we don't actually use the tick lower and tick upper, which are the actual parameters of the chunk. We use these instead. So the strike is a certain tick, and then the width is supposed to be the width of the position between the tick lower and the tick upper. So effectively, how this works is to specify a certain tick lower and a tick upper, you pick whatever strike you want to be in the middle of your position. So directly in between the tick lower and the tick upper. And then to get your actual tick lower and tick upper, you add the width divided by 2 to the strike, and then you subtract the width divided by 2 to the strike. And so the width is actually interpreted as the width times tick spacing in the contracts. So if the tick spacing of the pool is 10, then and you want to specify a position with a tick lower of 0 and a tick upper of 100, you would specify a strike of 50 and the width of 10. And according to the calculation, you would add 100 or 10 times 10 equals 100 over 2 is 50 to get the 100 tick upper, and then you do the same thing for the tick lower, and you get 0. So sorry for the long-winded explanation, but this is effectively how the positions are specified in the SPM. And then if we go through here, we can see how they're actually minted. So the entry points here, and so we do allow token transfers. They have been disabled in Panoptic v1.1, so you'll probably want to ignore those. But yes, so yeah. So anyway, yeah. So when you mint a position in the SPM, that ERC 1155 balance with your position size is minted to you. We emit an event, and then we validate the token ID. As I mentioned earlier, this will check if the risk partners on the token ID are correct. and then all of the parameters are within acceptable bounds. And then this will actually go through and execute all of the required actions in Uniswap required that you need to create your position. So if you have a short position, if you have a short leg, this will add liquidity to Uniswap. If you have a long leg, this will remove liquidity from Uniswap. And then there's also an option to swap, which I'll talk about in a little bit. But yeah, so if you go to create position in AMM. So yeah, effectively how this works is we go through and we loop through all of the different legs of your positions. This Panoptic math get liquidity chunk is how you convert each leg of your token ID to position size, and so you'll see a little bit what I was talking about there. And oops, that's actually not. Or here, create liquidity chunk. Whoops. Yeah, wrong contract. All right. So yeah, if you go to panopticmath.getLiquidityChunk, this is in the libraries folder. So yeah, as I mentioned, the option ratio allows you to set a multiplier for the position size for each leg, and then the actual amount of liquidity that you add to Uniswap is the amount of token 1 or token 0 on either side of the position. And so you'll use this is kind of the same as the Uniswap's get liquidity for amount 0 function. And you'll use this to determine how much liquidity to add to Uniswap. And then this tick lower and tick upper performs the tick lower equals strike minus width over 2 calculation that I mentioned earlier. So yeah, calculate how much liquidity to add to Uniswap there, and then we actually add it here. So if we go over here, create leg in AMM, we have an internal liquidity. We have an internal liquidity tracker in the SPM that tracks how much liquidity a given account has added or removed in a certain strike. And I should also mention that token type is used as a discriminator in the position liquidity, so you can't remove liquidity from a different token type. They're kind of treated as segregated pools for each user. But yeah, anyway, so we have an internal liquidity tracker. The ERC 1155 token balance, well, as I mentioned, it specifies the position size to the position sizes to mint and burn. It's not really a source of truth. So the actual source of truth is the liquidity that is added to Uniswap whenever you mint and burn position balance in the SPM. So you can have like different rounding things with this, and there can be dust ERC 1155 balance. The important part is how much liquidity you add and removed. So we calculated the liquidity earlier in Panoptic Math, and then here we're just we're adding it or removing it to the liquidity trackers, and then we are actually adding it or removing it to Uniswap after that. So if we look at the trackers here, you'll see there's a couple of them. There's this current liquidity tracker, which is kind of we store all of the liquidity in here, and we have the starting liquidity and the removed liquidity. So the starting liquidity represents the liquidity that's actually in Uniswap. So if you sell an option position and you add a certain amount of liquidity to Uniswap, it will be added to this tracker for your account and for that token type, tick lower and tick upper. So that's the one tracker, and then the other tracker is remove liquidity. So if you sell a long position, the liquidity that you remove will not be removed from it will not just be removed from starting liquidity. It will also be added to our removed liquidity. And the reason why we track remove liquidity separately is is to do our premium calculation. So as I mentioned earlier, the options buyers pay the option seller a certain multiplier on their on the Uniswap fees that their position would have earned had they kept their position in Uniswap. So this multiplier is actually determined by the utilization of the liquidity. So if only a very small fraction of the liquidity has been removed from starting liquidity, the multiplier will be pretty close to 1. But if 90% of the removed liquidity has been removed from the starting liquidity, the multiplier will be more than 3x. So this ratio is kind of what determines the multiplier. But anyway, yeah. So we update the trackers here. This is relatively straightforward, I think. And then we actually mint and burn the liquidity in Uniswap. And if you go over to mint and burn liquidity, these are just going to be Uniswap v3 pool.mint and Uniswap v3 pool.burn calls. This is relatively straightforward. So yeah, if we go over here, we minted in Uniswap, and then that goes through our Uniswap v3 callback function that transfers tokens from the caller to the Uniswap pool. And yes, this is relatively simple, I think. Just go back to the other. Go. Yeah. So yeah, we mint the liquidity or burn the liquidity in Uniswap based on the position specified in the token ID. After that, we collect any fees from Uniswap that were accumulated in that chunk for that account. So yeah, if we go over here, we store like a fees based value for the account, and then we compute the current fees based value and essentially manually calculate an amount to collect. Now this is probably one of the main things that changed between our Uniswap v3 and our Uniswap v4 implementation. Uniswap v4, the first difference, I guess, is that whenever you mint or burn liquidity in a certain chunk, it will automatically collect any fees that have been earned in that chunk. So if you remove liquidity from Uniswap, then effectively any fees that have been collected from that chunk, they will be added. They'll be collected immediately, and you won't have to call the collect function or anything like that. They're just distributed, or whatever tokens you're owed are just distributed directly to you. So you don't have to like compute an amount to collect, then collect it from here. You'll effectively just you'll get it in your account automatically, and then you'll have to settle the delta. So that's the one difference. And then the other difference is that Uniswap allows, or Uniswap v4 allows you to put a salt parameter for liquidity positions that you mint. So you can kind of segregate different positions with the same tick lower and tick upper. And this way we don't have to keep track of different fees collected between different SFPM accounts and do this thing with the accumulators. We can just kind of take the amount to collect as a source of truth from Uniswap, and then use that to determine how much fees to, or how many tokens to transfer to the account. So yeah, this is probably one of the main things that changed in our v1.1, and you'll see how we handle that after. But yeah, anyway, we compute the fees base from Uniswap, and we add it to that fees base that you saw used in that previous function. And so yeah, that's pretty much it. There's also we also compute this multiplier, as I mentioned. So basically, we have, and this is not really used in the SFPM. This is used by protocols built on top of it, like Panoptic. But there's an accumulator for long positions of a certain chunk and short positions of a certain chunk. And if we go over here to, where's this? S account premium owed and S account premium gross. So for short positions of a given chunk, this is how you calculate how much premium they earned from both the Uniswap pool and from long positions kind of owing premium. So, and then this is how much long positions premium owed. So kind of the idea behind this is that we compute these values, including the multiplier that's based on the liquidity utilization. And there's actually there's a Desmos link that I'll go to that will show this. But yes, here. So this is kind of the progression of the multiplier. The Panoptic pool limits liquidity that you can remove to 90%. So this is the effective limit. But yeah, as the utilization of liquidity that people have added goes up, the multiplier on the Uniswap fees that long positions owe also goes up. So we have kind of this we have this progression here, and it caps out at 3.25x. So that's what I was talking about there. And those two accumulators, and you'll see in this Desmos, I kind of replicate the calculations that are done in smart contracts. But yeah, those accumulators kind of define how those fees are transferred between long and short positions. So if a protocol inherits or builds on top of the SAPM, they will add these accumulator values to users who create positions through that protocol. And then whenever they close their position, they'll kind of take the difference of the accumulators and multiply it by the amount of liquidity to figure out how much premium they owe or are owed. That's kind of the idea behind that. And we have this formula that's described above and in the Desmos. I won't go through and explain it now, but yeah, effectively this formula is a way to define those accumulators such that the long positions pay that multiplier on the Uniswap fees, and then the short positions receive the Uniswap fees plus whatever multiplier the long positions paid on liquidity that was removed. So that's kind of the other mechanism that's in the SCPM. Besides that, and this is a read function that you can use to get those accumulators that I mentioned earlier, and then also compute it up to the current block if it hasn't been poked. So yeah, I guess that's the SFPM, and then I'll go through. Let's see. I will go through our changes to the SFPM, and then I'll do kind of like a quick overview of the rest of the protocol. Most of the interesting parts, as I mentioned, will probably be in the SFPM. The rest of the protocol is almost the same. Obviously, there's a few changes because of you have to convert tokens into Uniswap currencies, and then use Uniswap prices and stuff like that. But otherwise, it's mostly the same. So I have the SFPM diff open here. I can go either or the second. Nope, that's the wrong diff. So yeah, these are both the same diff. Let's see. Okay, so yes, this actually, yeah, maybe I think, yeah, maybe Aramis, we can make a note to update that. I think the diff number 2 is the same as diff number 1, but yeah, so this is the diff number 2 is actually going to be between this, and then between this. So yes, v1.1.x is our port to Panoptic v4, or not Panoptic v4, but Uniswap v4, and this is what's actually going to be in our Cantina repository, and it's mainly going to be the code that you're auditing. So anyway, yeah, let's go through the changes to the SFPM, and I'll kind of just scroll through this and mention some of the most salient ones. So yeah, obviously our mappings between Uniswap pools and the pool keys are going to be updated to use the Uniswap v4 format, and then we'll use the pool manager instead of the Uniswap factory. So yeah, these are all changes, but yeah, so let's look through the important ones. So yeah, the big one, or the big architecture change, I guess, is that Uniswap v4 does not use swap and mint callbacks. Instead, they do kind of a catch-all unlock callback, and then you can do kind of any action, so swaps, mints, burns within that callback, and then all the token deltas are kind of settled at the end of the callback. Now, Cantina just had the Uniswap v4 contest, so I'm sure you guys are familiar with it. But anyway, yeah, that's the general idea. So we're not going to do callbacks on every action. We're going to do all of our Uniswap actions for a certain SFPM action in one callback. So that's kind of the difference there. Effectively, what we've done, and I'll go. This will make a little bit more sense in context. Let's see. But yeah, so on the burn tokenized position and mint tokenized position functions, which are usually the entry points that you use to mint and burn positions and do all of your actions in Uniswap, instead of calling this create position in AMM function directly, we call this unlock and create position in AMM. And basically what this does, and it's really simple. If we go over to this function, it calls the unlock function, and it's over here, in Uniswap with the parameters to the create position in AMM function that you saw previously. So we call the Uniswap with that function. It sets the unlock state to true, and then it will go over to our actual unlock callback implementation, which is down here, and it will call the create position in AMM function with the data we passed in. And then, yeah, in this actual create position in AMM function, and we'll go over here. Let's see what the main changes are here. Yeah, so if we go over to create leg in AMM, instead of doing this Uniswap v3 pool.burn.mint, we do our modify liquidity with the amount of liquidity. So overall, we're doing the same action. You'll see here that we get the fees accrued here instead of collecting them. So that whole collect flow with the account fees base tracking has kind of been ripped out. So you won't really have to worry about that. But anyway, yeah. So we modify liquidity. We get any fees accrued on that balance, and you'll see that we use the salt feature that I mentioned earlier. This position key that we use for the salt is, I think it's probably somewhere up here. It contains the account that's minting the position, as well as the like the token type of the position, the tick lower, the tick upper. So this allows us to, so the fees that we're accruing here are only the fees that we actually received on that specific position for that specific account. So it's a really easy way for us to segregate between different accounts that are using the SFPM. So yeah, effectively what we're doing here, we're doing the same or similar to the Uniswap v3 pool.mint and burn functions. This is the Uniswap v4 modify liquidity function. And then the key change is that we're getting this fees accrued, and then we're returning it and using it to calculate our stored premium values with that multiplier I was mentioning earlier. But yeah, so we do that, and then we do our, instead of doing the callback functions, we just do all of our settlement here once we compute the cumulative delta. So yeah, we do the burn and mint in the pool manager, and I guess another important difference is that the semi-fungible position manager for Uniswap v4, instead of transacting in the native tokens, it just does the Uniswap v4 currencies directly. So when you're interacting with the SFPM, you acquire some Uniswap currency, you approve the SFPM for that currency, and then it just transacts between yourself and the SFPM directly with those Uniswap ERC1155 currencies without actually like wrapping or unwrapping any of them. And you'll see how we do that, how we handle that elsewhere. But yeah, effectively, that's the SFPM. One more thing that I guess I'll mention is the swaps. So the SFPM, when you if you go over to the mint tokenized position function, you'll see that we have some parameters called slippage tick limit low, and slippage tick limit high. These parameters are kind of the maximum and minimum acceptable prices after creating the position. And if you swap the order of these parameters, so if you pass in a slippage tick limit low that's higher than the slippage tick limit high, um, it effectively acts as a flag to perform a swap in Uniswap. Now, basically, the idea behind the swaps is to realize those payoffs that I was mentioning earlier. So if you create a USDC position, so you borrow your token type is USDC, you borrow USDC from the Panoptic liquidity providers, and you use that USDC to create a Uniswap position. If the Uniswap position at that time is worth or is fully in USDC, then you'll just use the USDC you borrowed to create the position in the SFPM directly, and that works out fine. But if the position is if the current composition of that liquidity is ETH and you borrow USDC to create your position, then you would need to swap that into ETH first if you wanted to create your payoff. So instead of using your own ETH, you can swap the ETH that you borrow from the Panoptic liquidity providers into the correct token. So that's kind of the idea behind that. And effectively, it's just an optional way to perform a swap in Uniswap, and these slippage tick limit low and slippage tick limit highs help you to make sure that your swap doesn't have too much slippage. But yeah, effectively, so if you set a certain token type for a certain leg, and you mint that leg with a different, and if we go over here, this will probably make more sense. So if we look at these ITM amounts, so yeah, if you have a certain token type and you mint a leg with that token type, and that leg, the liquidity composition of that leg at whatever time you mint it requires you to add a different token. So token type is USDC, you add ETH. Any ETH that you're required to add to that position will be considered an ITM amount, and then you'll swap for that amount after you mint essentially. So we have this swap and AMM function that calculates how much to swap, and we do that calculation here, and then we perform swap and Uniswap. So that's relatively simple, and the only change here is that we are just doing the Uniswap 4 changes the convention for the swap deltas, so they kind of flip the signs there. But otherwise, it's kind of similar. So that's the SFPM. I think I covered most of it. I guess I'll pause here for questions. I probably talked for a while, but yeah, just let me know. Or Aramis, can people raise hands in here?
They can either raise their hand or just drop the question in the chat, and I can jump in and read it out for them if they'd like.
Yeah, so I'll pause for questions here just for a little bit if there's any. I probably just talked for a lot. So yeah, I'll pause for questions, and if there's not any, I'll do a more brief overview of the other contracts, and then that'll be it, I think.
I can see someone typing.
There's a few people typing, so just wait for a bit.
The suspense is killing me.
Okay, so yeah, good question. Other high-level changes, I would say no. It's pretty much exactly the same system. I did mention that whole fees-based system is gone, and we're not tracking the fees base anymore. We're just kind of collecting. We're getting those token deltas directly from Uniswap and using them to compute the actual multipliers and using it to figure out how much tokens to send to each account. But that's not really. It's kind of like the same API. It's just like a different internal change. So other than that, the system pretty much works exactly the same way. There are a few minor changes. The ITM spread fee, which I'll talk about later. But effectively, one of the commission fees used to depend on the Uniswap fee for the pool, and now it's fixed at a flat 20 basis points. But again, that's a really small change. So I would say the system overall is pretty much exactly the same, besides the API change to Uniswap before, and all of the necessary supporting changes required to make that happen. I think that's probably it in terms of questions. Unless you had another one. Perfect. I think I covered the SFPM main Uniswap before changes there. I will go through the rest of the contracts. So back to the Uniswap v3 version of the contracts. In the Uniswap v3 version of the Panoptic factory, or Panoptic v1. Let's see what we do here. The Panoptic factory effectively deploys the Panoptic pool and the two collateral trackers that make up a Panoptic system. So if we go through the flow here, we get the Uniswap pool, see if it's valid, and then we initialize it on the SPM. And I mentioned the purpose of that earlier, just to generate the ID for the pool. And then once we do that, we create the Panoptic pool, and this is just to save the gas costs. It's a transparent proxy. So instead of deploying the whole bytecode, this is just a clone of an existing reference contract. But otherwise, it works pretty much exactly the same. So we deploy the Panoptic pool, and then we deploy these two collateral trackers. We clone this, and then we initialize the Panoptic pool and the collateral tracker. The two collateral trackers are initialized with their respective parameters. This Boolean effectively just determines which token the collateral tracker is supposed to be on of the Uniswap pool. And then we enter in the Uniswap tokens here, and then the fee of the Uniswap pool, and the actual address of the Panoptic pool. So the Panoptic pool can call some permission functions on it. And then we start the Panoptic pool with, of course, the Uniswap pool, the tokens, and then the collateral tracker contracts. This is essentially just deploying the contracts to the Panoptic system. We increase the observation cardinality of the Uniswap pool. We use the Uniswap v3 TWAP oracle pretty much exclusively. This allows the Uniswap oracle to take enough observations. Our front end and other users are kind of expected to make the assumption that a Uniswap pool has a certain number of observations before starting to trade. And that assumption is kind of it's enumerated in like the autoscope section in the contract. This effectively just allows the Uniswap pool to increase its cardinality if it has not already done so. And then once it's increased to a high enough value, then people can start safely using the Panoptic pool. So this essentially just expands the range of it, and then observations will be taken as swaps and mints and burns occur. And then after that, we mint a certain amount of full range liquidity to the Uniswap v3 pool. And this is kind of a fixed amount based on if one of the tokens is WETH, we have a fixed amount of WETH that we add to it. And then if neither of the tokens are WETH, we just add like kind of a smaller amount of liquidity. This is just to remove any liquidity gaps in the pool, if there are any, and make the user experience a little bit better. So yeah, we do. That is something we do, and anyone who creates the Panoptic pool will have to pay a little bit to add this liquidity to the Uniswap pool. And in return for this, they get an NFT. The NFT is not really in the scope of the contract, so I won't really discuss it. But it's cool. It's dynamic. It's based on the Uniswap pool. It's essentially like a little trading card that you get. But yeah, that's how the Panoptic factory process works. It's fairly simple. So you just create the contracts. You do some state initialization with parameters based on the Uniswap pool, and then you go through and add some liquidity to Uniswap. You call this increased observation cardinality, and then you mint an NFT to the person who paid for this full range liquidity add. So yeah, overall pretty simple. And there's like it's a mine pool address function that allows you to mine for like some simple vanity addresses on Etherscan. Again, not really interesting in terms of auditing. So yeah, this is Panoptic on Uniswap v3. Now, in terms of changes in Uniswap v4, there are a couple, primarily because instead of moving or instead of storing state in the contract at initialization or in the proxy contract that gets deployed, we're using the clones with immutable args pattern instead. So the parameters of the Panoptic pool and the collateral trackers, instead of being just like set in an initialized function you call, they're added to the actual code of the proxy contract, and they're passed in call data and processed by the Panoptic pool. It's relatively straightforward, and we have some diagrams to help you out with the layout there. But yeah, effectively, the difference in the deployment process, and this unlike callback is all just to support that full range liquidity add. But yeah, the interesting part in terms of auditing is, yeah, instead of doing just a regular clone contract, we do the clones with immutable args. So we're using, if you go up here, we're using that clones with immutable args for address. So anytime we call clone here, we're doing a clone with immutable args, and we're just passing in some data to append to the contract that's appended in the call data to the reference contracts whenever you call it. So effectively, it functions the same way. You pass some parameters into the contract during the deployment process, and then whenever you call the proxy contract, it gets those parameters, and then it uses them during the operation of the pool. So we're passing in kind of similar parameters here to the collateral trackers. We're specifying what the Panoptic pool contract is. We're specifying whether it's token 0 of the Uniswap pool and token 1 of the Uniswap pool. We're passing in the tokens and then the fees. So kind of same data, a little bit of a different process, but overall pretty similar. Panoptic pool, yeah, we pass in the collateral tracker addresses, same as before. So this is going to be kind of interesting. This will make more sense once I go over to the Panoptic pool. But instead of using, so previously in Panoptic v1, to get Oracle prices to determine whether an account was liquidatable, or to determine whether an account had enough collateral to mint a position, we would use the Uniswap v3 TWAP Oracle. So we would grab a bunch of observations from the Uniswap pool and use them in different ways. Obviously, in Uniswap v4, they know Uniswap v4 no longer includes the Oracle by default, and it doesn't like query that data by default. So we can't necessarily rely on a Uniswap v4 pool that we deploy on having support for that. So instead, we allow any user who's deploying a Panoptic pool to specify a Uniswap v3 pool to use as an Oracle before they deploy. Now, this interface is basically just all of the Oracle-related functions that we use on the Uniswap v3 pool. Technically, you could make a Uniswap v4 hook that did the same thing if you wanted, and then use that. So that's kind of an option that's available to you. So this is why it's IV3 compatible Oracle and not just iUniswap v3 pool. But yeah, for the purposes of this contest, we're just assuming that it is a Uniswap pool. And effectively, we're querying observations from the Uniswap pool in the same way that we were in Panoptic V1. The only difference is it's not actually the pool we're trading on. It's now a different pool that we're using as an oracle, if that makes sense. So anyway, yeah, we pass in this oracle and then also a key to the Uniswap v4 pool. Then we create the pool with all these different parameters. And this we still need to do some state initialization. For the collateral trackers, it's just like the initializing the shares and stuff like that. But yeah, mainly, and this is just doing like token approvals. But most of the data is now in the clones to the mutable args pattern instead of being in state variables. So yeah, that's kind of the changes there. And then otherwise, we upgraded that full range liquidity add to Uniswap v4 instead of Uniswap v3. But otherwise, things remain pretty much the same in the factory. So yeah, those are the changes there. I don't think I'll go through. I'm not going to go through the like whole Panoptic pool and collateral tracker, just because like those were already audited in our last audit, and mainly we're just auditing the Uniswap v4 diff here. But I'll go through the changes here. There aren't generally going to be a lot. There's going to be a lot less changes, I should say. But yeah, for the collateral tracker, the primary changes here are just the wrapping and unwrapping of Uniswap v4 currencies. So as I mentioned earlier, instead of using native tokens to create to kind of like transact between the Uniswap pool and its users, it just uses the Uniswap v4 currencies directly, so it doesn't have to wrap and unwrap every time. So in Panoptic v1, the way the collateral tracker worked is you would deposit or mint. You would call the deposit or mint ERC4626 functions, and some tokens would be transferred from your account to the Panoptic pool. Here, kind of a similar thing happens, except the tokens are first wrapped to Uniswap v4 currencies and then transferred to the Panoptic pool. So there's going to be some extra logic in the collateral tracker to handle that and make sure that works well. But yeah, so go through here, and this is the clones with immutable args thing I mentioned. It is in all of this data, which was previously just in state variables that were initialized during the deployment process, is now in call data that's passed to the reference contract. So this is kind of like a diagram of the addition to the call data. And then the library has functions to get the parameters at different offsets. It doesn't have them for some types, so we wrote a few custom ones ourselves. But yeah, effectively, we just get these parameters that are encoded at different offsets in call data instead of the state variables. So it's pretty straightforward. Yeah, let's see. So initialize, we remove all of these state initializations because those are in the clones with immutable args function, or in that pattern now. Yeah, so main change, as I mentioned, is just the Uniswap v4 wrapping callback. So there's this settle token delta function that's going to be called by the Uniswap mint or burn functions. This handles the unwrapping and wrapping of currencies to and from Uniswap. So yeah, basically, it's fairly simple. If we are transferring tokens to, or if we're depositing into the collateral tracker, we sync on Uniswap, and this is anyway. Probably most of the people auditing this have the context of already having audited Uniswap before, so you know how the sync settle flow works essentially. But yeah, we call this to have Uniswap v4 snapshot the balance of the pool manager. Then we transfer some tokens, some native tokens from the collateral tracker depositor to the Uniswap pool, and then we call settle to turn that into a Uniswap delta. And then finally, we call the mint function, which transfers the Uniswap ERC6909 currency to the Panoptic pool. So that's kind of like the minting flow. And then if a user's withdrawing tokens, then we do this. Then we do the burn, which is relatively simple. We just burn the ERC6909 currency from the Panoptic pool which creates a Uniswap delta. And then we settle that delta by calling take and transferring the tokens from the pool manager to the user. So that's effectively the new flow that we added there. Let's see, what do we have? Yeah, so instead of doing these token transfers, we're doing settle token deltas. Users who are interacting with the collateral tracker will notice no difference. The flow works exactly the same. They're still going to be transferring native tokens. The only difference is this extra step in here to wrap the native tokens into Uniswap currency before transferring them to the Panoptic pool. So we scroll through the rest of the changes here. And then there's also the one that I mentioned in response to that question about the ITM spread fee. This is a little bit different. This is going to be a commission fee, a flat rate commission fee, so it's not set to something times the pool fee on initialization. It's just like a constant immutable value that's the same for all collateral trackers, regardless of pool. But yeah, overall the flow there is kind of the same, so not too much to audit. So yeah, that's the collateral tracker. So again, main changes there are just that wrapping from ERC20s to ERC699 currencies, and vice versa. So those are the changes on the collateral tracker. That's pretty much it. Now on the Panoptic pool, we have this same kind of shift from using state or a state initialization process where we just put all of the pool specific parameters in state variables in the proxy to putting them in call data instead. So we have this kind of same thing where instead of reading from state variables, we have these functions that extract the data at a certain offset from call data and get that. Again, that's relatively straightforward, I think. As far as mechanical changes to the Panoptic pool go, the primary difference is just the usage of the Oracle contract instead of the native Uniswap pool that the Panoptic pool is trading on. So we pass this Oracle contract into the Panoptic pool, and all of the Oracle observation functions, and you'll see there are a bunch here. We'll use this Oracle contract to get observations from Uniswap. So we have a couple different Oracle prices that will retrieve those observations. We have a fast Oracle price, which is effectively just the median of the last 3 Uniswap observations. We have a slow Oracle price, which is the median of a different distribution of Uniswap observations. The slow Oracle is currently not in use. It's kind of a mode that can be enabled or disabled based on a constant. And then we also have the internal median Oracle, which is kind of an internal array of ticks that's updated with the last Uniswap observation every time someone mints or burns an option or calls a poke function in the Panoptic pool. So those observations are also queried from our Uniswap v3 Oracle contract. And then we have a TWAP Oracle, which is used during liquidations, which uses the Uniswap TWAP functionality, the observe function, and then uses that to figure out a price. So effectively, 3 different oracles that query Uniswap observations are now moved to this external Oracle contract that we allow users to specify. Now, of course, users can specify any contract they want in there. We don't verify that it's valid. So for the purpose of the contest, we are assuming that it is a valid Uniswap v3 pool. And we'll also, of course, validate this in our UI and all those sort of things. But anyway, so main changes here. Wherever we use the current tick, for the current tick, we are still using the Uniswap v4 pool current tick. The main reason, we're using the Uniswap v4 tick. We're not using the tick of the Uniswap v3 pool. But for all of those Oracle ticks, we are using that Uniswap v3 Oracle contract. So if you scroll through the changes here, you'll see that they're mostly minimal except those Oracle changes. This is just adding an unchecked block, just a small gas optimization for something that can't overflow. You'll just see we're changing all of the Oracle usages here. Then yeah, we're just doing the v4 tick instead of the Oracle tick there. Yeah, so that's pretty much it for the Panoptic pool. I think again, most of the vast majority of the changes are in the semi fungible position manager. The changes to the Panoptic pool and the collateral tracker are very trivial. A lot of them are actually just that switch to clones with immutable args, and then some small changes to make sure it works with Uniswap v4. But yeah, the semi-fungible position manager, lots of changes overall. The main thing is just that we're doing the entire option minting and burning flow inside of the Uniswap v4 unlock callback instead of having those individual callbacks on mints, burns, and swaps. And then we have removed that account fees base tracking system and the collect calls to Uniswap, and we just replaced it with trusting the amount collected that we just pulled directly from Uniswap. So that's the main scope of the changes. There's also a second diff in the contest. That's a very small diff since our last C4 audit. I'll go over that briefly and explain the changes that we made there. There are just a few. So yeah, one of these changes, and I'll scroll through here. Effectively, there was an issue discovered in our last C4 audit where S underscore pool assets could technically be 0 if somebody used all of the available tokens in the pool to mint options. So we just handled that case here. Very simple. And then the other major issue that was discovered, I mean, these were both low severity issues. But yeah, if we go, this should be in the Panoptic factory. This is an interesting one, actually. Yes. Okay. There was kind of like an out there issue described about reorgs. So previously we were using the clone function here to create the collateral trackers. We were already using create2 for the Panoptic pool, where you can specify salt, but we were just using a basic clone for the collateral tracker. And what this essentially means is that the only thing that determines the collateral tracker address is what order the collateral tracker is deployed in relative to all of the other Panoptic pool deployments through the Panoptic factory. So there was an issue described where there could essentially be a reorg, or somebody could detect a transaction in a mempool or something of somebody creating a Panoptic pool through the Panoptic factory and then depositing into one of the collateral trackers. And the issue was essentially that the reorg could make it such that a different Panoptic pool was deployed before another Panoptic pool, and the collateral tracker address could change. And somebody could theoretically leverage that to force someone to deposit into a malicious collateral tracker. So anyway, really, really low probability, low severity out there issue. But that was the other kind of fix that we made since our last audit. These are very small in scope. All the other changes in this diff are pretty much just common fixes. So yeah, that's pretty much it for our second diff. I think I've covered both of these diffs here pretty comprehensively. But yeah, let me know if anyone's still here. Let me know if you have questions, or if you want me to cover anything else in the protocol that's not in the diffs a little bit more deeply. No, those two fixes that I described were the only significant changes since our last audit. There were some significant findings before, but those have been fixed. So prior to the last code that has been audited, those two fixes that I went over were the only two that were there.
Cool. It
Right.
looks like that might be the final question.
Well, if there's nothing else, we can probably end it here. I think I pretty much covered everything. Oh, there might be another one from Dimitri. So the three oracles are implemented in the exact same way in terms of actually getting the observations from Uniswap and computing the oracle prices. The only difference is that the Uniswap pool that they're being queried from is not the Uniswap pool that the Panoptic pool is actually trading on. So the Panoptic pool will be trading on a Uniswap v4 pool, but the oracle prices will still be queried through a Uniswap v3 pool that's specified by whoever deployed that Panoptic pool. So the logic for getting the oracle prices is exactly the same, and you'll still be getting it from a Uniswap v3 pool, just like you do in Panoptic v1. It's just that Uniswap pool is not the same one that's being that the Panoptic pool is deployed on, if that makes sense. All right, perfect. Well, I don't think there were any other questions.
Perfect. Thank you so much for this. This was super in depth, and yeah, it was awesome.
All right, perfect. Well, if anyone has any questions that they think of while they're auditing, feel free to just drop it in the Discord channel and give me a ping, and I will respond relatively quickly. Otherwise, yeah, looking forward to having all of you guys review all of our code and hopefully finding no issues.
Thank you so much, everyone. Have a good rest of your day.